For the second example, the question's slightly changed. We've still got the number 3,000, but this time it's been rounded to the nearest 100 rather than the nearest 1,000. And we're going to do the same as before. We're going to calculate the upper bound and then the lower bound, and then we're going to write it as an error interval. So one more time, I'm going to draw a number line to show my possible values. 3,000 is what I've rounded to, that goes in the middle. But then this time we're rounding things to the nearest 100. So rather than going up and down by a jump of 1,000, we're going to go up and down by a jump of 100. So at the top here, I'm instead going to have 3,100. And then if I go down by a value of 100, then I'm going to go down to 2,900. Okay, so now to calculate the upper bound for part A, I'm looking at the top part of the region. The upper bound can be found halfway between these two values, like we did in the last one. So halfway up into this region, that's going to be 3,050. That's 50 into the middle and then 50 up to the end to make 100. And that's our upper bound. And again, we're not allowed to be this number, but that's the smallest I can make it. And on the low side, to do part B, the lower bound is halfway in between here. So I want to go 50 below the 3,000 or 50 above the 2,900. That's 2,950. And that's my lower bound. And again, this time we are allowed to be this number as well, because that still rounds to 3,000, just like it did over here. So upper bound is that one, lower bound is this one. And then the error interval, well, you put x in the middle, write down your inequalities to show that it's in between these two values. It's less than the upper bound at the top, 3,050. No line, because we're not allowed to be 3,050, but we are allowed to be equal to 2,950 at the bottom. And there's your error interval.